The next problem that we're going to solve is also a problem coming from web work. It says the region between the graphs of y is equal to x squared and y is equal to x to the power of 3 is rotated around x is equal to 3. Find the volume of the resulting solid. Okay. The first thing that we want to point here is that now we're doing a problem where we're rotating a region about a vertical line. X is equal to 3, it's a vertical line. What does that mean? Right away we have to put it in our head that this is going to, finding this volume, okay, is going to be integration, definite integral from a to b of what? Of the area of the slice of the solid, whatever that's going to result, either a disc or a washer, but in terms of y dy. So please be careful there. If we rotate around around the y-axis or a vertical line parallel to the y-axis, we have to integrate in terms of y. Okay, next is what? Let's sketch these functions in order to find the bounded region. Okay, so this is the y-axis and the x-axis. Okay, y is equal to x squared, standard parabola, y is equal to x to the power of 3. Well, this is not, obviously it's rescaled, right? It should be way steeper, but doesn't matter. It's a line, right? It's a linear function, 3x. So the first thing that we want to do, this is the bounded region, okay? The first thing that we want to do is find out the points of intersection. Okay, so how to find the points of intersection? That's quite easy. We just put these two functions equal to each other, right? X squared and 3x. X squared is equal to 3x, bring 3x on the other side of the equation, factor x times x minus 3 is equal to 0, either x is 0 from here or this factor yields x is equal to 3. And this is important, okay? Why? Because it says that this point here is exactly 3. And why this is important? Because they ask us to rotate around the line x is equal to 3. So x being equal to 3 means this vertical line. So we will find the solid if we spin this region about this line, okay? So if we do that, what do we get? We get something like this, right? So this was the bounded region. We rotate that about the y-axis and we get, oops, sorry. Sorry about that. So this was the bounded region. We rotate that about x is equal to 3 and we get this solid, okay? So on the side you can see how it is going to be. It's like a cone, but then the emptiness is obtained by this quadratic function y is equal to x squared. Now, the important part is what? If we take a slice, of the solid, we can see that again we obtain a washer, right? So this is going to be that's going to be the disk, and then within the disk I have an empty space right here. So what do we have to figure out? We'll have to figure out how much is capital R, right? And how much is this part here, small r. Okay, in order to do that, again, I have the same region sketched again, and I need, what do I need? I need the axis of rotation and the bounded region. Okay, we will measure the radius always goes from the axis of rotation to the bounded region. So now one more time I'm reminding you, because we are evaluating the volume of the solid obtained by rotating a region about a vertical line. The volume is going to be obtained by integrating this washer in terms of y. Okay, so that means how much is the big radius for any given y. Okay, so let's say for this y, how much is going to be the radius? The radius again goes from the axis of rotation to the outside bound of the bounded region, right? Okay, so let's see. For this particular y, this is going to be the big radius, right? And the question is, how much is this part right here? Why? Because this distance, we know how much it is. This distance is constant 3, right? I want to know how much is the big radius. Well, then the question is, I can express the big radius if I know this distance. But this distance is determined by this y, because this is nothing else but the line y is equal to 3x. This is the line y is equal to 3x. Well then, how much is going to be x in terms of y? That's y over 3. So this distance here, obviously, is the distance x. For this particular y, this distance is x. How much is x? X is equal to y over 3. Okay, so I have this distance from the origin to the axis of rotation. I have for every single y, let's say this y, right? This is going to be capital R now, right? This is going to be capital R. How much is this part going to be? For this particular y, that distance is simply the distance x, but I'm integrating in terms of y. So how much is this y? Sorry, how much is this distance in terms of y? Again, that's x in terms of y, that's y over 3. So for any y, the capital R is simply going to be the distance 3 minus this distance right here. And that distance in terms of y is y over 3. So we obtain capital R. By the same logic, we find the small r. Again, we measure the radius from the axis of rotation to the inside bound of the washer, right? So this is going to be the small radius for, let's say now, this y. This is going to be the small radius, right? This is constant 3 from the origin to the axis of rotation. The question is, how much is this distance? Well, again, for this particular y, that distance is simply x. But how much is that x in terms of y? Well, this distance here, right, is given by the parabola y is equal to x squared. Well, how much is x in terms of y? Obviously, square root of y. If I take this y, right, how much is going to be the small radius? This is r, right? The whole distance is 3 from the origin to the axis of rotation. The whole distance is 3. How much is this distance? This distance is going to be x. How much is x in terms of y when we're talking about the quadratic function? That's simply square root of y, right? Because this is nothing else but y is equal to x squared. So we have found the small radius. Small r is equal to 3 minus square root of y. From here, the area of the washer is equal to pi, sorry, my mistake, right? Right away I made a mistake. Not a of x. The area of the washer is going to be a of y, because I'm rotating the region about the vertical line. So pi times capital R of y squared minus small r of y squared. And now simplify this is very easy. Pi times 3 minus y over 3 squared minus 3 minus square root of y squared is equal to pi 9 minus 2 times 3 times y over 3 plus y squared over 9 minus 9 plus 6 square root of y. Square root of y squared is just y, so minus y. Okay, and then we can cancel 9 and 9, and we get how much? We get pi, this cancels out. Okay, so I have negative 2y minus y is negative 3y, y squared over 9, and then plus 6 square root of y, which is what? The area of the washer. Now we can come back to the beginning and we can evaluate this as the definite integral. We said that a of y is equal to y squared over 9 minus 3y plus 6 square root of y dy. Okay. The only thing that we're missing here is what? How much is a and b? And again, don't make this mistake. A and b are not 0 and 3, these two that we found the points of intersection. Why not? Because these are the points of intersection in terms of x. Well, that's not difficult, because just to evaluate what are the coordinates of the same points, well, this is just the origin, 0, 0, right? So the lower bound of integration is 0, and then I know that here x is equal to 3, and then plug here either in x squared or 3x. 3 times 3 is 9, 9. So the coordinate of this point is, the y coordinate of this point is 9, so you integrate from 0 to 9. Okay, now it's just Cal 1 question. This is y cubed over 27 minus 3 over 2 y squared plus 6 times y to power 3 over 2 times 2 over 3, and this whole thing evaluated from 0 to 9. And then this is what? 9 times 9 squared over 27 minus 3 over 2 times 81. This cancels here, and you have plus 4 times square root of 9 to the power of 3 minus 0 if you plug the 0 for at this antiderivative. And then I don't know how much do you get here. You get 3, which cancels with the 9 here, so that's 9 times 9 over 3 minus 243 over 2 plus 4 times square root of 9 is 3 cubed is 27. And then you can cancel this also. You get 3 here, so 27 minus 243 over 2 plus 4 times 27, which is equal to 2. This is 2 times 5 times 27 minus 243, and then I don't know, 270 minus 243 over 2. Again, if I did not make any mistake here, I get 27 over 2. And this question is question 16 from workbook number 7, right? So this is question 16 from workbook